On July 16, 1945, at exactly 5:30 a.m., humanity entered a new era in history. The event took place in Alamogordo, New Mexico, where the world's first atomic bomb was tested. Behind this test was years of intellect, patience, and hard work. However, leading the complex engineering project of the atomic bomb was the renowned scientist J. Robert Oppenheimer. We know that atomic bombs are incredibly powerful, but how do they actually work? The science behind the atomic bomb. An atomic bomb works through a process known as nuclear fission. This happens when the nucleus of an atom is split apart, releasing an enormous amount of energy. But why is energy released? The nucleus of an atom is held together by nuclear forces, and it takes a significant amount of energy to keep them bound. When the nucleus splits, a fraction of that binding energy is released as explosive power. This chain reaction continues, leading to a massive explosion. The fuel for this reaction must be a heavy element, and the most commonly used one is uranium-235. However, naturally occurring uranium contains very little uranium-235, making it necessary to separate it from uranium-238. To separate uranium-235 from uranium-238, a method called gas diffusion is used. The uranium is converted into a gaseous state and passed through a barrier with microscopic holes. Since uranium-235 is slightly lighter than uranium-238, it moves faster and gets separated through a centrifuge process. The final enriched uranium contains enough uranium-235 to sustain a nuclear chain reaction, a quantity known as critical mass. When enough uranium-235 is brought together under specific conditions, it reaches a supercritical state, where an unstoppable chain reaction begins. Neutrons from one fission reaction trigger more fission reactions, creating an exponential explosion. This is what makes an atomic bomb different from a nuclear power plant. In a nuclear reactor, the chain reaction is controlled to release energy gradually, while in a bomb, the reaction happens instantaneously, causing massive destruction. In an atomic bomb, the nuclear explosion converts only about 0.1% of the uranium's mass into pure energy, but even this tiny fraction is enough to create massive destruction, all explained by Einstein's famous equation, E equals mc squared. The hydrogen bomb, 700 times more powerful. Interestingly, an atomic bomb is not the most powerful nuclear weapon. The hydrogen bomb is estimated to be 700 times more powerful than the atomic bomb because it uses nuclear fusion instead of fission. While the concept of an atomic bomb may seem simple, building one is an extremely complex process requiring advanced engineering and technology.